Hi, good day. My name is William Dongo. Here I am again giving you the lecture, the continuation of the climate control and refrigeration technology, residential and commercial heating. Okay, this will be a lecture lesson number 3A, the continuation for the mechanical component in the furnace. The one I'll be talking about today is a continuation. I'm done with the first one, number 1 and number 2. Now I'll be going to electrical, mechanical component in the air. And then number 4, electromechanical component in the inducer. Okay, we're gonna be talk about the limit control, bend control, rollout switches, fan switch inside furnace, summer switch, fan, sander. And then on the number 4, electromechanical component inducer, I'll be talking about the drop inducer, force drop furnace, and then the pressure and the centrifugal switch. Okay. Now, first one I'll be talking about will be the limit control. Limit control sends high furnace temperature duct to a malfunction. Reduce air flow, no airflow. Overfire condition. And then limit control can be wired in the 3 ways. In series with the gas valve circuit, in series with the transformer secondary, in series with the transformer primary. In all cases, the objective is to de-energize the gas valve and stop the flow of fuel to the burners. Limit switches will reset in 1 or 2 ways. Automatic resets doesn't require a technician to investigate the cause for tripping of the limit in most cases. Manual reset, push button. As with any manual reset devices, it is recommended that a technician investigate the cause of the tripping. When replacing a failed defective limit control, never set it higher than the setting of the switch being replaced. And then we have the bend limits, not found on all furnaces. Detects poor venting. Hot combustion products roll back into area where this switch is installed and switch opens. Operates like a limit and shuts off the gas valve, usually manual reset. That means you gotta go there personally and reset it yourself. But make sure you find out the reason why first. And then you got the rollout switch. Rollout switch like limits and bent limits rollout switches responds to temperature. Rollouts are placed near the opening where burners enters the heat exchanger. If bending problems occurs, play can roll out of the burner area looking for oxygen. The rollout switch senses the higher than normal temperature and opens the circuit to the gas valve. These switches are primarily used if you got overheat surfaces somewhere and it's abnormal. These limit switches will close it out, will trip the circuit and stop the furnace. Wire in series with gas valve circuit. Fusible link type of switch, make sure the replaced by, and then this one must be replaced by a technician. Okay, technician must correct this problem. All limits, bend limits, and rollout switches open on a rise in temperature. Never wire past a limit, bend limit, or rollout switch for other than test purpose. Find cause of problem and reset switches or replace switch if needed. And then we're gonna talk about next is the fan switches inside the furnace. Then start and stop the fan motor, normally open, control close on a rise. Wire in series with blower circuit, that's the fan circuit. Delay start of fan is 1 to 2 minutes after main burner ignite. Okay. Delay stop of fan 1 to 2 minutes after the main burner is off. Several types. We got temperature on, temperature off. And then you got time on and temperature off. And then you got time on and time off. Adjustment can be made for different duct condition. Delay on time to reduce circulation of cold air in plenum, not usually above 150 degrees Fahrenheit. So if you exceed this temperature, then the limit switch will stop and then it will stop the fan. And stops everything because you don't want no overheat inside the furnace. Delay of time for increased efficiency, not usually below 90 degrees Fahrenheit. Not all models have both adjustment. Read manufacturer's information sheet when installing new switch. Okay. And then we have the next one is the summer switch. You got the summer switch right here. Summer switch, on some older furnaces, there is a switch installed in the furnace that will bypass the fan control, causing the fan to run continuously until the switch is shut off. The summer switch is used to circulate air in the house without operating the heating or the air conditioning. Okay, and then you have the door switch. Door switch on all furnace manufactured since early, there is a switch located behind the blower access door. The purpose of that switch is to ensure that the blower cannot run once the access door has been removed. If wired correctly, all electricity must pass through the switch before going to any other control on the furnace. And then we're gonna have the fan sender. Okay, the fan sender on some furnaces that don't use a separate relay, a fan sender is used. A fan sender provides low voltage control of line voltage, fan, motor, and auxiliary circuits in heating, cooling, or air conditioning system. Fan central normally have 24 volts transformer and at least a single pole double throw relay enclosed in one assembly. The most common use of a fan center is to change the blower from one speed to another. When the G wire from the thermostat energizes the coil in the relay, the normally open contacts close and the normally closed contacts open. There should be a supply power at the common terminal of the relay. The high-speed wire from the blower should be connected to the normally open contacts. The supply wire from the blower should be connected to the fan control. The supply wire for the fan control should be connected to the normally closed contacts of the relay. And there are normally 5 low voltage terminals on the face of the transformer. They are R, which is the secondary, W, which is the heat, Y, which is the cooling, and G, which is the fan or auto, and C is the seasonal condition, common. No, C is equals to the secondary common. The R and C terminals are internally connected to the transformer. The G terminal is internally connected to the one side of the coil on the relay. The C terminal is also internally connected to the other side of the coil on the relay. The W and Y terminals are connected to the nothing. They are merely connection points. Repeat my last. The W and Y terminals are connected to nothing. They are merely connection point. When a pan sender is used, all wires coming from the thermostat normally connects to the face of the thermometer. And then we'll be talking about draft inducer. We're gonna go now to the electric mechanical components for the inducers. Draft inducers. Draft inducers, in order to raise the efficiency of the furnace to 78%, more manufacturers now make induced draft furnaces. Induced drafting is accomplished by small squirrel cage that is installed in place of the draft diverter. The draft induce pull the combustion air and gas mixture through the heat exchanger of the furnace. Because the combustion gases are being pulled at a regulated rate through the furnaces, the gas is being burned more efficiently. When the thermostat calls for heat on the induced draft furnace, the W wire from the thermostat does two things. Energizes the coil on the induced relay to start the inducer. The W wire also run through an inducer providing device. The inducer providing device is either a centrifugal switch on an end of the motor or a pressure switch mounted somewhere on the furnace. If the equipment is using centrifugal switch, the inducer motor will have 4 wires coming from it. 2 of the wire are 115 volts power supply. The other 2 are leads that are connected to the centrifugal switch. When an induced motor with a centrifugal switch reaches the 90% of full speed, the centrifugal switch will close. When the switch closes, the W wire from the thermostat will then be allowed to energize the gas valve, providing no limit switches are open. If the equipment is using a pressure switch providing device, that W with a wire from the thermostat must pass through the normally open pressure switch before energizing the gas valve. Some of the pressure switches prove the vacuum of the induced housing, providing the motor is running and the flue is not plugged. Other pressure switches probe with pressure of the burner compartment. Vacuum operated pressure switch and many more popular are more popular. And then we got a force drop furnace. Force drop furnaces. Force drop furnaces much rarer than drop induced furnaces. A force drop furnace pushes the product of combustion through the furnace. If the furnace is force drop, it will always have a sealed combustion. Sealed combustion means that the entire area where the burner are is sealed off. And then we got the pressure and the centrifugal. Pressure, if a furnace is drop induced or force drop, it is absolutely necessary that there is a way of proving that the inducer motor is running before the gas is allowed to come in. A pressure switch is one way to provide that the inducer is running. Normally, the pressure switch contacts are in an open position. Most pressure switches have a small rubber tube running between the switch and the drop inducer housing, providing the inducer is running at full speed and vent of the furnace is not plugged. The housing of the blower will create a vacuum. When the pressure switch senses the vacuum, the contacts will close. When the contacts is closed, the gas valve then open. The second way of proving that an inducer is running is with a centrifugal switch. A centrifugal switch only proves that the inducer is running. It does not prove that the vent is not blocked. Okay? A centrifugal switch is a separate switch that is mounted in the end of the inducer motor. When the motor reaches full speed, the normally open centrifugal switch closes. The centrifugal switch is usually wired in series with the limits and the gas valve. Okay, I'll show you some pictures. This one right here is L464 combination pan limit. Okay, this is a pan limit switch. This is a diagram of the pan limit switch. Okay, you got here is just like a dial that you turn around to set your temperature. And then this one right here is a bimetallic okay, when this coil is heated up, and then it will make a contact, and then the diagram of the switch will be like this. And then over here you got pan center. And then this one right here is a diagram where on the basic heater. Okay. And then this one right here is a limit control. Then you get the one here just like a duct where it's and then this one right here is the limit temperature switch, in which the diagram will be right here. Limit switch. This one too, it's a limit switch. And then Same thing here, it's a limit switch. And then this one is a fan control switch. Controls the blower right here. This one is inserted into the duct, and then again, this is the switch. Okay, that's all I got for this lecture, and then thank you very much. And then this will complete the lesson number 3. The first one is lesson 3, and then the one I made right now is lesson 3A. I thank you very much for watching my video, and this one is for training purposes only, and I don't really intend you that this is what you gotta do, but this was for information and training purposes only. If you go out there in the field, it's up to you how you gonna, and not liable for any accident that will you incur. But for you, for this lecture is for you to help you to get the information out, the basic of all this equipment. I thank you very much, and thank you. Bye.